Welcome to Module 4 of our course. This module will focus on account lockout vulnerability. We'll start with helping you understand the core of this concept. We may talk of an account lockout vulnerability if an authorizing script which monitors the number of login attempts is set to lock user accounts after a limit of failed logins has been reached. If an account is blocked without blocking the IP address used for attempted logins, a potential attacker, who has obtained the username and attempts to log into its corresponding account, may exploit this by blocking the account of a normal user. The attack results in a denial of service and may cause users additional problems. This authorization mechanism is frequently implemented in online banking. If a user submits a valid username but enters an invalid password for 3 consecutive attempts, the account is locked. To unblock it, the user has to contact a branch or call a helpline. The procedure could be helpful in preventing attacks, as the potential attacker has only 3 guesses at the correct password for the targeted username. On the other hand, anyone who has acquired our username may use it to successfully deny us of our own bank accounts. Take a look at the example of how this mechanism works. We can see here a simple website created in PHP. The site employs a simple database-based login mechanism. As we can see, a PHP session mechanism is being utilized here. We're connecting to a database. Let's see if the session has successfully started. If it has, load information from the database on whether the account is locked. If it is, simply stop the execution of the script. Here's the part responsible for logging users out. It deletes the session variable which identifies users. If the session is correct, a displayed message notifies users that they are logged in and may log out. If the session fails, a login form will be displayed. After sending the form, we may load data on the user who is matched to the given login. If we manage to obtain the information, it is processed further. But more on this later. If we're not successful, an error message appears. Now back to finding a user who holds the specified login. If the account is locked, we disable the login option and display a message stating the account is blocked. If the data is valid, declare a PHP session and display the link in the main page. If the provided password doesn't correspond with the password stored in the database, we first display an error message and then check the number of login attempts. First, the field will hold 0. The value will increase with each failed login attempt. If it becomes equal or greater than 2, this means that at least 3 failed attempts have been made. We display an appropriate message and block the account in the database, denying the user access to the account. If the limit of login attempts has not been reached, simply increase the count in the database. As we can see, IP address and special cookies are not checked here, which means that the account will be locked without regard to the computer used for login attempts. Let's see now how the service works in practice. For the purpose of this example, a user admin has been added to the database. The password is test. Let's try to log in using these credentials. We've logged in successfully. We may now return to the main page and log out. As you can see, the mechanism is working correctly. Log in again. Refreshing the page will display a message stating the user is logged in successfully. But let's see what a potential hacker could do with this situation. Switch to the private browsing mode. New cookies will be collected, and so a new PHP session will start. The user is not logged in for this session. The page opens and, as we've predicted, we're no longer logged in. Let's try to imagine how an attacker could exploit this situation. The attacker knows the admin account has been created in this service, either because he made a correct guess or because he acquires this information in some manner. Now submit an invalid password. The message displayed, unsurprisingly, states that the password is incorrect. Let's do this again. After the third failed login attempt, the message states that the account is blocked and the user must contact an administrator. This means that the attacker won't be able to try new passwords. The same message will display each subsequent login attempt. Let's see if this will happen. As we can see, the account is locked. Let's find out how this affects a user who is already logged into a service. Switch off Firefox's private browsing. We're back in the previous session. As you can see, the account has been locked. The session exists in the system, but the database stores information that the user is blocked. We can see that this mechanism could be a source of problems for normal users. A potential attacker could block a user account knowing only the login, and this information is frequently explicitly displayed on websites. All it takes to block a user is to submit several incorrect passwords. If this mechanism is implemented, for example, in an online auction service, an attacker could temporarily prevent the user from bidding in an auction. How can we prevent this attack? Blocking the computer used for failed login attempts is a better alternative to locking users out of accounts. This could be achieved, for example, by tracking and banning an attacking computer's IP address. There's little chance of the attacker and targeted users sharing the same IP address, and on the upside, this approach prevents normal users from experiencing problems, while we're still able to thwart brute force attacks on our service. That's all in Module 4. Thanks for your attention. The next module will focus on web parameter tampering. See you there.